what we're going to do first is we're going to create a new part, and this is going to be a part that's going to contain both our nut and our bolt. So first thing we're going to do before we've even created any geometry is we're going to save this part, and we're going to call it metric fasteners. Now, because this is going to be nuts and bolts, both of which have a hex head, we're going to create the hexagonal shape to start off with. So create a sketch on the top plane, and we're going to use the polygon tool. So click on polygon and drag a polygon shape out. We're going to use a 6-sided polygon. Obviously that's a hexagonal shape. Firstly, we're going to select one of the sides and make that horizontal. That will align it the way we want. And the next thing we're going to do is to create the diameter of the hex. All we need to do is select the circle, the inner circle of the polygon, and dimension that, and that will give us our shape. So for that we're going to go for a 13mm diameter shape. 13mm diameter is the standard size for an M8 metric hex. So we're going to then extrude that out. We're going to extrude it by 5.5mm because that's also the standard metric size. Now, before we go on any further, what we're going to do is start naming these features. Naming features is a good habit to get into, particularly when you get to very large parts, because it can become very difficult to work out which feature is responsible for what bit of geometry. So we're just going to call this hexagon, and we can also name the sketches. So I'm just going to call the sketch hex, and we can also name the dimensions within that sketch. This can be very useful, particularly you'll see why a bit later on. If you hover over these dimensions, you can see that we've got D1 at hexagon. So if we right click on that, on the left hand side we'll see this primary value is D1. So we can change that D1 to something that makes a little bit more sense, and if we call that height, that becomes the height of the hexagonal shape, and we've got this D1 here at hex, so that can become, if we right click on that, we can then call that the width. So that becomes width at hex. Now, as we're creating the nut first, what we need to do is to put a hole through here to form our nut. So I'm going to create a sketch on this top plane here, on this top face rather, and I'm going to simply make a circle, a center point circle, and because, as I said before, this is an M8, this diameter wants to be 8mm diameter, and you can see again this is D1 on sketch 2, so we need to make that make a little bit more sense. So actually, while that was open, we can then go and we can change this straight away. We can change that to diameter at sketch 2. We should probably just change the name of sketch 2 to whole sketch, and then we're going to do a cut extrude, and we're going to extrude through all, and that's our hole in the center. So just to I'll just change the name of that cut extrude to hole, and there we have it. Now, naming those things, while you're naming it, make sure you name it exactly the same way that I have, because that will be important for later on. Okay, so that's our M8 nut completed. There are lots of different sizes of nuts and bolts, obviously, and if we wanted to have a variety in an assembly that we're creating, we could go ahead and just save different files with different size dimensions. But there is a better way, a far more efficient and faster way, and that's called configurations. So within the single part, we can go to Configuration Manager, which is this center tab up here on the left hand side above the Feature Manager tree, and we go to the configurations. Now at the moment we've only got one configuration specified, that's the default configuration, so we can rename that. If we go to Properties, we can rename that to this particular one. Now we've created the M8 nut, so if I call that nut M8, hit OK, we have one configuration. Now if we want to add another configuration, we just right click on the top where it says metric fasteners, go down to where it says add configuration, and let's make an M10 nut. So we'll call that nut M10, hit OK. Now you can see it's changed to that one being selected. And what we can do next is we can start changing the dimensions on this part so that it becomes an M10. So if we right click on the width, we can then change that. It's 13 at the moment. If we change that to 17, now this is where you have to be very careful because it's very easy to make mistakes here. We have to select configurations, and if you forget to do this, you'll just end up by changing. By default, everything gets changed in all configurations if you change that dimension. But what we want to do is come up here and select this configuration so that this new dimension we've created will only apply to this particular configuration. Hit OK, and tick. If we update that, you can see that the size, the overall size has changed. We also want to change the height. So again, if you left click on it, you'll just change the dimension, and that will change it in all configurations. If we right click on it and we change it over here, we'll have it changed. We can specify which configurations it gets changed in. So we'll change that to 7, select configurations, and make sure it's on just this configuration. And you can also see that it specifies the M10, that's the configuration you're in at the moment. Hit OK, hit OK, update that, and our nut changes. And then the final thing is the diameter of the hole. So if we go to that, and we're going to change that to 10 because we've got an M10 nut, make sure it's on this configuration, hit OK, update that, and then we have our new size of nut. So okay, we're going to create one more configuration. Now this time we're going to add a configuration. We're going to call this a bolt, because we're going to create the bolt as a separate configuration. So this is going to be bolt M10. Now bolts have a length as well, so we're going to call that M10 times 50. So M10 x 50. So once that's done, instead of having this hole, we actually don't want that hole here. So what we can do is we can suppress that hole, and that will only suppress it in this configuration, in the current configuration we're working on. And what we want instead of that hole is obviously to have the shaft of the bolt. So we're just going to make a circle, create a sketch, create a circle. That shaft is going to be a 10mm diameter shaft because it's N10. Hit OK. Again, we want to change the name of this sketch because we want to have that as the shaft diameter. So I'll just call that diameter, and we'll probably change the name of the sketch as well. So we'll call that shaft sketch. And now we're just going to make a boss extrusion, and we're going to extrude that out 50mm because that's what we specified. And just going back to that again, we can select that dimension, right click on it, and we can change the name of that. So let's call that shaft length. Okay, so that's our bolt. So just going back to the configuration, so just checking to make sure that that's worked properly, that that's our nut and that's our bolt, and there we have it. We could of course continue creating new configurations, so we could create a new configuration for each one of the bolt sizes that we've got and each one of the nut sizes that we want. Doing that manually is a bit labour intensive, and there is actually a better way. In fact, as is typical with SOLIDWORKS, there's actually more than one way to add configurations quickly. The first way is through using the dimensions. So if you right click on this dimension, you go to configure dimension. What you can do is you can add, it will tell you what the dimension is in all the various configurations. You can also add a new configuration, so I'm just going to call this one new, and I'm going to use a shaft length on this bolt of say 20. If I hit OK, what it will do is it will have put in a new dimension, a new configuration in there. What I can also do though, which is a little bit more powerful, is if I do the same thing, go to configure dimensions, and down here there's a box that says all parameters. If I select that, that will show me every parameter, every dimension that is different from one configuration to the next. So that's really powerful. Then what I can start doing is I can change all these dimensions in the various so then I can change any of the either suppression states or the dimensions that exist in the configuration. So that's one way to do it. I can then just keep going through and just adding in all the information that I want. In some ways this is the best way. It's a little bit slower than the final way I'm going to show you, but it's definitely the most reliable, and it's probably the easiest way of quickly adding more configurations. So the final way of adding configurations into your part is through a thing called design tables. Now design tables are an amazing way of very quickly getting information in using Excel spreadsheets. So to do that we go to Insert, Tables, Design Table. Now again, there's a couple of ways of doing this. You can create from a file, so you can basically browse and select an Excel spreadsheet that you can import, and if this is done correctly, then everything gets set up for you immediately. It's very simple. The reality is that the smallest error, the smallest typo error or anything, but if there's the slightest error in your file, then you'll find that you'll come up with an error message and it just won't work. So what's a better strategy is to auto-create your own design table. And what SOLIDWORKS will do is it will look through your document and it'll find all the configurations and all the different dimensions that vary from one configuration to the next, and it will put it into a table for you. And again, this is an embedded Excel spreadsheet, and this can be edited in exactly the same way as any other spreadsheet. But what's really powerful is that you're able to import data from an existing spreadsheet. Will mean that the design table won't work. It'll just give you a fail. So there are ways around this. There are ways of creating design tables and editing them, which is far more robust, and I'll show you how to do that. Now this data from your spreadsheet that you created earlier can simply be cut and pasted into your design table. So you can select that data, paste it in place, and you can see there's a fair amount of data there. Now what you've got to do is basically go back to your existing drawing, and what it will do is the design table will create a new configuration for every single one of those instances which were in the spreadsheet. So if you hit OK, and if you've deleted some configurations that were already in there, like these two new ones that I created, it will just delete them automatically. So now if you go to the configuration manager, you'll find that you have configurations of all these parts automatically created. And there you have it. Okay, what we're going to do next is we're just going to make a new assembly, and we're going to put those nuts and bolts into that assembly. So because we've already saved that part, it's available to be put into the assembly. We might just let's put 2 of those components in, rather than going insert component new. If you want the same component to be in the assembly, you can simply select it on the feature manager tree, drag the part across holding the control key down, and then you have a second component. Now, to configure this component, what we do is right click on it, go down to configure component, and in this case we want to select a nut. Let's say we're going to have an M10 nut. Okay, and we'll configure this bolt to an M10 bolt, and then we're just going to mate these two together so that they're concentric. Just a single mate will do. And there we have a nut and bolt. The final thing we're going to do is just a linear component, linear pattern. So we're going to select, let's say, select both these components, and let's make a grid of say 3 by 3. Direction 2. Now let's just make 5 components. Okay, make 5 components, and what we want to do is just to turn these all into different, configure them so that they're different nuts and bolts, matching nuts and bolts. Okay. I won't go through and do that. I'll leave that up to you, and then that's the assignment completed. Just a final thing to remember: when you come to submit your file, submit the assembly file, and don't forget to also submit the part file.